It's been a long day, but I think we have a really important and exciting talk to wrap up today. I'm happy to introduce Rishiraj Pravahan, who's the principal data scientist at the AT&T Foundry. The AT&T Foundry is located, I believe, in San Jose?
In Palo Alto.
Palo Alto, okay. Palo Alto, California. I was pleased to meet him when I sent out a word to my broader network about finding an instructor for a course in the program, and we got together over that. Rishiraj worked for the ATLAS experiment at CERN as a PhD student and a postdoctoral fellow. While there, he worked on constructing, commissioning, and calibrating the ATLAS detector, as well as on software techniques to analyze the massive data set from the Large Hadron Collider to search for new physics. Here's a guy who comes out of big science. He has also been a passionate teacher and advocate for science through public talks and seminars in the US, Europe, India, and Latin America. He's been collaborating with Udacity to produce content toward a nano degree in data science. And his current work involves understanding distributed systems, networks, privacy, and security of customer data collection, storage, and analysis of sensor data, and making advances in the frontiers of statistics and machine learning. And he's going to talk to us today about learning, practicing, and teaching, a glimpse into the profession of data science. Please join me.
Thank you, Anna. I'm actually giving the talk on time. Never in my life in physics seminars I got to speak at 4:30 for a 4:30 talk. So please stay awake. If you make it till the end, you'll find a Hadoop cluster under your seat. So it's a joke. So what is this talk about? Here's a selfie in 2006 that I took inside the ATLAS detector. I don't know if you guys are familiar with this. So there's this machine called the Large Hadron Collider, which is in Geneva, Switzerland. And one of the experiments there is the ATLAS experiment. And the idea is to collide protons with each other and produce lots of particles and search for new ones. So I had the amazing opportunity and luck to actually build part of the detector. It's just a dream of a lifetime. And so I was a rat lab rat, sorry. So now I'm a unicorn, apparently. So that's actually from a book called Unicorns Among Us. I'm not plugging his book, but just took his cover, so I really like it. But I don't want to talk about myself, but my experience of transitioning from, sciences, from physics, from academia to industry. And so there seems to be a collective confusion about what or who is a data scientist. And I overheard one of my colleagues say, we all work with some data, so everyone is a little bit of a data scientist. And actually, this is not a really bad statement. I mean, I think it's a feeling among a lot of people in industry that if they work with some data, they are data scientists because they do scientific things. Sure. So, and there is a clear definition lacking for what or who is a data scientist. And if you look in, let's say, LinkedIn, you have more than 100 different job titles for what is a data scientist, a data engineer. I made that one up, data hipster. That's for Palo Alto. So actually, the data science is an interdisciplinary field, and it can be approached from many different sides. So of course, we have the computer science, AI, software engineering people. There's the stats and the math people. Also a lot of people who come from economics, finance, business, or certainly the hard sciences like, not that other sciences aren't hard sciences, but physical sciences like physics, astronomy, biology, earth sciences, so on. And so there's this whole hodgepodge of professions that actually, and people have different degrees in data science. And then there are these multifarious skills that they bring from their different backgrounds. So all of these, we have people, for example, in our team who have machine learning backgrounds, Markov decision processes, lots of Monte Carlo experience, lots of people with very formal training in math and stats. I come from the scientific background, data collection, pattern recognition. We had a wonderful talk about designing experiments, of course, hypothesis testing. And we have people from the business side, those who understand what is the business value that we are bringing to a data science team or using data science. So this is very important. Of course, one of the most important things is communication. And I think that goes in all of these, that it's a required skill. But it comes a lot from the people who are coming from the business side and so on. And they're very valuable. So there are many, many roads that lead to data science today. And you guys, some of you guys are involved in one of them. So there is the traditional, you can do one of the STEM degrees, bachelor's, master's, or PhD, depending on when you wanted to call it a day and start making money. One of the programs I really like and we recruit from a lot is the Inside Data Science, which is a nice program where they take PhDs and postdocs from a lot of the physical sciences, physics, biology, astrophysics, and they give them a sort of fellowship for a few months, and they produce something, a product. Of course, there's a lot of people who come to data science from industry. And these are people who have been, I mean, my company is a classic example. We have, Claude Shannon worked for my company. So at one point. So AT&T, we had the Bell Labs, we have a lot of people who have been working here for a long, long time, and 20, 30 years, and they have incredible expertise in very specific systems. And we give them training, internal training, and I'll talk about this a little bit more later on, to become more acquainted with the techniques of data science. And they're excellent engineers to start with. Of course, there are apprenticeships and internships, and there's this thing called Institute. You guys might want to check it out. They're getting a lot of traction. There are, of course, online courses or massive open online courseware.
And the Masters of Information and Data Science.
Absolutely. I was just going to plug you. So, and Udacity and Coursera, of course, I'll talk about Udacity a little bit more. And then there are these hybrid programs where you have university, and almost all universities now, as in this MIDS program, where you have a very significant online presence and also a significant presence within the industry, and how there's a exchange between what we are doing in the industry and what we should teach. So in my opinion, a data scientist with any other name will still do the job. I mean, that's what's important, the skills. So first of all, we should know what is the demand for within the industry. This is what needs to be clear. Or even for a given job, what is the demand, the skills that the job demands, and what should one learn to fulfill this demand. So technical skills are always necessary, but seldom sufficient. We look for people with great technical skills, but that's not all. I mean, you can be the best mathematician in the world, but if you can't actually formulate your problems, you can't plan and execute and deliver results and products, and motivate your things in the business case, you're not the right fit for industry. So this is something you have to think very, very hard about, that it's not just the technical skills. I mean, I myself come from a very technical background, but I had to develop the other skills, and it just doesn't come, and you're not born with it. You have to sort of develop all skills, and so this is something to keep in mind. So I'm going to go into a little bit detail about learning itself. So my beginning was kind of pure in fundamental scientists. And in fundamental sciences, you have this philosophy of positivist reductionist philosophy. You know, it started 500 years ago. Physics is an old subject, and it's inductive and deductive, as we saw today in one of the talks. There's a lot. The Facebook guys, I mean, they described how you use induction and deduction in data science. But in sciences, this is the way to do things. You prove something and you generalize it and so on. So also understanding causality. I mean, why things work the way they work is very, very important in sciences, in physics. It's okay, A is correlated to B. If I wrote that in my thesis, my thesis advisor would not have really passed me. He would have said, go find out why, right? So also, this is very effective in general. So my work, my physics that I discover on Earth is the same as the physics that I will discover in Alpha Centauri. And that's something very important. However, in data science, it's not always the case if you think about it. So science, to a lot of people who start in the physical sciences, is very pure. It's a calling. And they join it to answer this calling. And this is how I got started. And in data science, it's a little bit of a duality. It's not that in data science people are not using these things, the ones I mentioned before, but there is something more. There's something quicker and faster, and this is what I wanted to point out. There's a lot of empiricism in data science. You have a posteriori analysis. You don't always have the luxury to construct a nice theory, supersymmetry. And now I'll work out all the equations about it. I'll write down the Feynman diagrams, and then I'll go build a machine and see if I can find a particle. This is not happening in data science. Data science is about looking at the data that's coming out and constructing something out of this data. So it's a lot more a posteriori analysis. And the method of learning, of course we use induction and deduction, but we also use transduction. That's a word I learned from Vapnik's book. So it's machine learning uses this where you bypass this inductive and deductive step into directly deducing thing from the data. I shouldn't even use the word deducing, transducing thing from the data, right? It bypasses this process. It's very, very practical. It's very, very useful, and it's very, very immediate. Your answers are there, and that was something that appealed to me a lot. I mean, I had to wait around, talk about data and not being clean. I had to wait around 2 years for data because one of the magnets exploded. I don't know if you guys heard about this. So that's how it works. I mean, if you actually invest your life in an 8-year, 10-year plan in academic endeavors, and sometimes you want immediate results. You want to see people smiling and happy and give you a bonus and so on. So, I mean, so data science, for this science, for the data scientist kind of becomes a method or a tool that you use to extract certain results. And scientists who are hired from a physical sciences background need to learn to make this transition. I don't know how many of you guys had either some sort of degree in physical sciences or natural sciences. Anybody? Oh, there's quite a few people. All right. So I'm sure at some point in your lives you had to make this transition. And also the standards of success are different. In industry, often the case is that you get to measure things not because they're actually scientifically proved to be great, but you measure things because it works, it sells, it's immediately effective, and it's actually helping somebody in your business or in outside world, whatever. So the standards of success is redefined, and you must redefine yourself and your work to meet these standards of success. And often, I mean, when you're from the natural sciences, you think, oh my God, I did not discover the Higgs, so I'm a failure. So this is not the case in data science, which is good. So data science today, I feel, is learning about the mechanisms and manipulability of systems that emit data as an exhaust. And using this exhaust and through an a priori analysis of the data using scientific, statistical and mathematical and computational tools. So I like this sort of diagram where you have a complex system and you take the data that comes out of the complex system and you try to rebuild another complex system, another set of gears. And sometimes it's not always the complete picture, right? Some of the gears are left out, but it's an approximation to what was happening in the first system in the first place. And this is how data science works today. You just see, if I turn this knob might get turned and this gear might be affected. And this works really well. I mean, we can anticipate communication failures, prevent loss of infrastructure, urban planning as one of the talks we saw today. We secure transactions with it. So there are many, many examples today of exactly this, where just the data that is collected from the system can be reused to make a model of the system. I like this quote from Bertrand Russell very much. So physics is mathematical, not because we know so much about the physical world, but because we know so little, it's only its mathematical properties that we can discover. And this is very important because in data science, I feel in the future, in the foreseeable future, data science will be a way to understand general causal behavior. We have talked a lot about correlations and how correlations are not causality, and that's absolutely correct. But I think there is a way we can slowly, we are going towards that, where we will use data science to extract causal behavior. And the way to do that is to model complex, nonlinear, multidimensional interacting systems and at larger and larger scales. And this is incredibly, incredibly difficult to do. I mean, this is part of multidimensional systems that we completely ignore. And if you think about deep learning and all that, or most of data science today is very linear. If you think about it, I mean, a lot of the tools are linear algebra, and some of this is completely not applicable because of non-linearities there, and we kind of like ignore it. But not all of us. So in fact, the future is here. So this is where I work. It's a little bit different from what you would think as AT&T, and that's the point. So we are an innovation center, and our motto is we make ideas. And not just that, we make products. So it's a very nice open workspace in Palo Alto. We have teams from every part of AT&T. It's not just data scientists. We have engineers, we have software engineers, we have business guys, we have marketing people. So it's almost like what you would think is a startup. It's a little bit, it's a collaboration between AT&T and Ericsson. And what we are really trying to do is understand systems. So things that we work on. So this is the practicing part at the Foundry. So we are doing things like understanding the core network that is part of AT&T's infrastructure, and using the data that it generates. So when you heard about the traffic problem and how you have like cars and roads and so on, there's traffic on the internet. And this is something, and one of the nicest things is you can zap packets. You can't zap cars. So we can understand the network using data science, and a lot of skills that goes in there, graph theory, people in network engineering, people who have done a lot of research on optimization, and of course understanding complex systems. We also have projects that optimize distributed data storage. So we have so much data. I mean, this is a company that's producing about exabytes of data. And that's not like in a year. I mean, it's in a short period of time. And we have so much data that we need these distributed data storage systems to store them. Of course, we have, and with that comes all the pain of storage. I mean, it's cheap, but that's the only good advantage of storage. Actually, everything else is difficult. There is, of course, we want to improve customer experience, and a lot of data science work, innovation goes into that. We have connected cars and connected buildings projects, and we are building sort of a big data analysis platform where we can do all these kinds of work. So it seems a lot of work, and we are a team of 40 people. The idea is to come up with solid little projects. We do basically 6 to 12-week projects. We have an incredible culture of collaboration and innovation. I talk to startups all the time, probably more than I should. These projects are firmly grounded in business goals. And the most important thing is we try not to black box them. We don't try to throw a solution that is ready-made at a problem and then another solution comes out. This to me, it doesn't work. So we need to get people who are thinking into that data, into that system, and try to understand the details of it. So there are engineers and scientists from various backgrounds, and as our director likes to call it, it's the people that counts. It's the data scientists. So if you want to make a team, you look at the people who are in the team, and that's where you want to optimize, and that's where you will get the best results. So I wanted to point out that the pitfalls of data science are the pitfalls of bad science. So if you are doing bad science, you will get bad results. And this is very important, and sometimes it's very tricky, because in industry, you have the tendency sometimes to redefine your objectives and say, oh no, this is exactly what I wanted, in fact. Yeah, I'm successful because I'm on my 4th quarter, and yeah, we have to start a new, that's really something we have to watch out for. So part of practicing good data science is to validate your conclusions, is to validate what you're doing. And the other people who talked here touched on this. And to identify a degree of belief in it. I think this is very important and a lesson that we can draw from academia, where if I say, oh, the mass of something is 125, you will say, well, what does that mean? But with a confidence limit of 99%, then it actually makes sense. This is actually not a sort of pedagogical thing or pedantic thing. It's actually something very important. I had a conversation with a CTO of a very large company, and this person was very interested in having confidence limits in risk analysis. He wanted, so they got all these risk analysis for their week of what are happening and what are the intrusions in their system, and they were like, I don't know actually which is more reliable and which is less reliable, and how do I judge these things? So probabilities and confidence limits are important. Moreover, you want to check and validate. We had certain graphs about precision and recall. I mean, you want to calculate these things and make sure the experiments that you designed, and like Elena's talk, are giving you the right answer. So how do we do that, and how do we spread the word? I remember one of the speakers mentioning we need a bunch of evangelists, data evangelists going around teaching people how to actually do these things. So we thought the same thing, and we made a program for internally. We decided we needed to have AT&T employees come up to speed about these things that we are trying to say. So we started actually building a course with Udacity, which is one of the MOOCs I talked about. And the course was on building robust scientific models, or model building. And of course, that comes to robust scientific minds. I mean, you learn how to think through the process. So we try to break out every problem into like formulating a question, making a model, and validating this. And it was myself and my colleague Don Dini, we developed this. So there's a little part of the thing, and I'll keep talking while I play that. So while we were developing this coursework, we started realizing that people come from these different backgrounds, and they need a different sort of background material to come to this class. And so we started thinking that there needs to be a defined sort of prerequisites. And then we realized that it doesn't exist, and we had to make this. Through this process, this nano degrees thing was born as a collaboration between Udacity and AT&T, and it's been launched now. So that was a big deal this year. So that's pretty much my talk. I don't want to just go through my conclusions. You can read it. The idea is that data science is here to stay. And so let's enjoy it, and let's have a dialogue. Thanks.
Okay, questions for the final speaker here. I'm glad to hear that data science is here to stay.
Yes.
Any questions? Are we all worn down? And
did anybody look for the Hadoop cluster on the
Yeah.
for the what?
I have a question, yeah. I have a question for you, yeah. So the works you are doing at AT&T Foundry, are they open source, or, I mean, can we access those, whatever you are doing at AT&T Foundry, are they available to the general public as a open source project or something?
Yes.
Okay. And also I went to the website, so I need to register. I mean, is it only for someone paying $75 a year to join that program, and then they can submit their idea? How do things work there in AT&T Foundry?
So the Foundry is a part of the company, and you have to actually get a job to kind of submit ideas there. But I mean, in general, maybe I didn't understand what the $75 was.
I went to the website. It says
for AT&T? Oh, maybe we can take this offline, and I can clarify.
Okay, why don't we have one wrap-up question here?
What is your least favorite thing about being a data scientist apart from ETL?
Least favorite thing? Wow. I did not anticipate these kind of questions. No, I'm just kidding.
Maybe you should add to it afterwards your favorite, so we don't end on a really down.
All right, yeah, maybe. I think it's Paradise Lost. I think it's not working on extremely difficult scientific problems. And that, I think, is something that I have always grew up doing. I mean, it's just, I'm not working on the universe anymore. I'm working on people. And people, as one of the speakers mentioned, is a very non-linear system. And they make decisions. And they don't follow natural laws or any laws. And it's a very different difficulty. And it's a loss of structure. It's a loss of what he said, paradise. You know, it was beautiful. And I think that's the most difficult thing. The most positive thing is, again, exactly that. Because now it's a system that I have very little experience with. I've started, and I have these tools, and I have this understanding. And how do I actually bring all these things that I've learned somewhere else to understanding people? And this is, people have been trying to do since the War of 1812. And so, not literally. It's
Even
just,
before.
yeah, even before. So I think the challenge is different, and that's one of the most fascinating things about it too.
Great. Well, listen, thank you again.
Thank you.